going on here? Hang on. I am meant to be here. Yeah, button soldered. What happened then? Also, is the background music going? No, I don't think so. I can't actually tell. I can't see the... Yeah, okay. The, oh, I know what it was. There was a loop. I'm going to go back to... I'm going to go back to here. And I'm not going to mess around in OBS anymore because I'm just going to screw it up. There was music. Yeah, and then we stopped. Okay. I'm just trying to log back into... where are we? I'm logging back into CastNote. Streaming. Okay. Welcome to your little dose of chaos. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And good morning to all of you wonderful people. Hang on. Okay, I've got CastNote open. I can do this for real, properly. All right, hang with me. Sorry. Good morning to Michael Wires, Tinker, Relware Tap. Yes, Pete, we know who you are. You're upside down in... Yeah, you're living in the upside down. And the back to front. John Whips, Amanda is here. Any Mules, who's this one? Silver Pond Deep. I can't actually see the rest of that name. Scott Pillar, Sharky, Stephen George, Ilix, Paul Schultz is here, Grant is here.
Said, are we there yet?
I think we are there. I think we are. Okay. So that is the... Where's the chat? Here is the chat. But I do need to turn the volume up on the TTS. So I'm just cranking that up a bit now. Hopefully that'll do the job. Never activate the omega-13 device. Said Andy. Oh. Michael says, upside down, I'm operating on a 57-degree angle only. A full 180 rotation requires too much energy. Well, you are being sucked towards the center of mass of this enormous ball on which we are living. Okay. I was just going to say, it's 4 minutes past the hour. There is no way that I can get on topic now. That would just be breaking the rules of the universe. Crispian is here. Also Simon, good morning. So, what we are going to do today is open this bag and try to connect what is in it and see if we can get any sensible stuff coming out of it. Tinker says, things I learned, Toyotas go sideways when you stop the wheels turning. Tinker, do not slide your Toyota sideways. So that the trick is you keep the wheels turning and you keep moving in the direction of rotation, not lateral to the direction of rotation. Michael says, is it a squirrel emitting device in the bag? Yeah, anything can be a squirrel if you try hard enough, and it's not related to it's not related to what you're meant to be doing. Oh, Tinker says, city seems to have run out of road salt. Right. So, yes, okay. So you have an ice situation where the coefficient of friction between the surface of the road and your tyres has fallen below the threshold required to stop it from breaking away and taking you off sideways down the street. That is a sad situation. Hopefully, and he says all road vehicles should have mandatory Omni wheels. But hopefully there was no bad outcome. Tinker, are you okay? Is your car okay? Is everything else okay? Did you crash into an ice cream store? Or maybe a place that sells bags of ice? Or an air conditioning shop? What are the other places that you could have broken, that you could have smashed into running onto ice? Oh, Paul says, feel free to ignore. I'm not going to ignore you, Paul. Just changed my YouTube handle. Did it work? I can see your Paul_Schulz. Yeah, I think you were P. Schulz earlier. I can't remember exactly. Also, good morning to Rob V. Imi is here as well. Crispian says, I've an aftermarket remote locking system which allows me to lock the car running occasionally. Okay. Tinker, you have a full beer fridge and a supply of munchies. Gonna stay home now. That's good. And Michael says, my car is completely safe, hasn't moved in several weeks. Yeah, that is the most use. It's not the most use you can have for a car. Now, okay, so people have said, what is the topic? The topic is that, Gavin, well, thank you. You look good too. The topic is color sensing. So we are going to experiment. Oh, that's right, I almost forgot. While I am getting onto the topic here, throw out your nerd brags. Nerd brags for the win. I know Amanda had one. She sent me a picture and a message earlier. I think. Anyway, I'm not gonna
At Railway
preempt.
Dep said, colour with a U or without?
Always with a U. Always with a U. There is no colour without you, Pete. No colour without you. Okay, so has the caffeine hit yet? I don't know. I don't think it has. So what am I looking at? Okay, I've just got to make a little bit of bench space. I've got a test jig sitting here running on my bench. Wondering if I should shut it down to move it. No, I've got enough room. I can work around it. Okay, I'm going to grab a prop and wave it at you to explain what is going on and what my plan is. Now, as many of you will know, I have had a very painful relationship with RGB LEDs. They break my mind. They are. I'm talking about the classic WS2812/2813/2814 style RGB LEDs, the addressable ones, and the reason is that they are extremely fragile in manufacturing. If you order a product with WS2813s or something on it, you kind of take it for granted that they're going to work when you get them. But what you don't see is that the place that has done the assembly has gone to a whole lot of trouble to make them work. They have to be stored in very well controlled environmental conditions, and then even if they are stored in good environmental conditions, like in a proper humidity control cabinet, etc., ideally you then need to bake them for, I think, sometimes up to 3 days beforehand. That's an extreme, but often for like 24 hours they need to go into an oven to be baked at, I think it's typically like 60 to 70 degrees Celsius, and then they have to go from the oven straight into the machine and straight onto the board and then straight into reflow. if they are very hygroscopic. So they suck in moisture, which then expands when it goes through reflow and causes problems. So the lens that is over the top of the RGB LED, if you stick your fingernail into it, you can feel that it's slightly soft. It's kind of like hot glue. It's that sort of thing. And I have wasted so much time and money going through assembling devices with RGB LEDs on them and had ridiculous failure rates and had failures that are really frustrating. Like, I go to all the trouble of assembling boards, plug them in, test them, the LEDs work, and then you put them aside for a couple of days and you plug them back in and the LEDs fail. And it drives me nuts. So I have this love-hate relationship. I suppose it is a love-hate relationship because I love the RGB LEDs. I love RGB LEDs when they work, but I hate them when they fail. And they are horrible. Horrible. So, a little while ago, I spat the dummy. And this, I mean, I can show you this on stream because it's I'm not actually showing you anything confidential in this relation. This is a board this is a CAN bus control, like joystick input CAN bus control board for controlling the water cannons that I've told you about many times over the years. And there's an RGB LED on here, which is a status LED. That, up until not that long ago, was a WS2813, and they would fail really frequently. So I ended up spitting the dummy and putting on a through-hole RGB LED. So if you look at this LED, you would think that, where is it? There. You would think that it is just a regular 5mm through-hole LED in a hard cast package. Thing is, it's got 4 leads, not 2, and it is addressable. It's actually the chip inside it is set up the same as a WS2812, which means that it is GRB, color order, instead of RGB. But apart from that, it's the same as a 2813. And these have been 100% reliable so far. We've made many boards with these LEDs on them. Never had a single one fail, either in assembly, in testing, in the field, or whatever. So I am, yeah, I am relieved to have come up with some kind of a solution to that, because we can get these. So these addressable RGB LEDs in the 5mm, and I've also got an 8mm version in the through-hole package. They just come in a bag, loose, like regular LEDs, and we can't pick and place them. Obviously, we can't reflow them, but what we do is reflow the rest of the board, then we put the LED in and solder it in by hand and cut the leads off. So it's an additional manual process, but the payoff in terms of knowing that it's going to work every time greatly outweighs the pain of not being able to do it. Okay, there are a few things in the chat that I should check. Okay, so Paul asked, are you using a camera or a photodiode? And the answer is kind of neither. It is specifically a color sensor. I'm going to get to this in just a moment. The one that I'm looking at, if anybody wants to look up the part number, it's a VEML3328SL. In fact, I'm going to VEML3328SL. I'm going to pull this up on the screen so that you can go and, got to get it onto the correct monitor. And what button? That button. Okay. So this is the thing. It's a color sensor that outputs the luminosity at different wavelengths. So it's not just brightness, it's actually telling you what color is being detected. And it's this weird little rectangular package. So yeah, we're gonna be diving into this in a minute. But first, I'm going to finish this story and yeah, so you can kind of think of it as being like a 1-bit camera, I suppose. So it's got sensors for IR, C? What is C? I don't know. BGR, and yeah, so what is C? It specifically measures at 5 different wavelengths. It'll tell us somewhere. 16-bit resolution for each channel. Supports low transmittance dark lens design, integrated modules, color sensor and signal conditioning, 2.6 to 3.6 volts, I2C. Yes, we shall get into this in a minute. And this particular thing, C. What is C? Blue, red, green, IR, and C. Come on, tell me what C is. Now, I am getting far too much into this. So that's the little Duvalaki devicey that we're going to be looking at in just a second. So, what else was going on in the chat? David says, I have no color sense. Well then, what you could do is we'll make up a special pair of glasses with one of these sensors mounted on the glasses pointing forward, and it can speak colors to you. Where just dropping through the quickly through the chat, catching up. Okay, Amanda said, nerd brag number 1.
At Amanda_RFT said, have 5 brags this week, John.
That is just greedy. You've got to save brags for follow-up weeks. But okay, let's get them out. Nerd brag 1 has got to meet Emma Watkins, Emma Memma, formerly of the Yellow Wiggle. Yes, I'll get back to the nerd brags in a second, but Andy just said, aim for nothing less than the color sensing of a mantis shrimp. Yeah, I talked about this a couple of weeks ago, I think it was. I can't remember. It was recent anyway. The mantis shrimp, so the way color sensing works in different types of eye structures, including the human eye, is that you have different receptors in the eye which are sensitive to different wavelengths. And this is where the classic, rods and cones and all that sort of stuff comes into. And I'm going totally from memory here. I may be wrong, but I think humans have like typically three. Some people who have a genetic aberration have like 4 specific wavelengths that they can detect. And some animals have fewer, some have more. The world record, I think, is the mantis shrimp, and there's some other animal that can distinguish something like 11 different wavelengths. Like they've got more sensitivity. I have a feeling that dolphins might be very high as well, like 7 or 8 different wavelengths. Yeah, I can't remember. Hang on. Okay, so where are we? Okay, nerd brag number 2 for Amanda was, had my last day at uni on Thursday and only have 2 assignments to complete before Christmas. Awesome, so close, so close. And yes, and congratulations, as Pete said. That is awesome. Nerd brag number 3 was promoted by St John Ambulance Australia, New South Wales to Grade 5 Divisional Officer and Acting Officer in charge of the Cessnock Combined Division. Wow. Very impressive. Amanda, you're on a roll. And nerd brag number 4 got the trophy for the most duty hours at our Divisional St John presentation night last week. You did the most duty hours and you've just been finishing studying. That's ridiculous. Okay, where are we? Next, last one. Nerd brag 5. On a more personal note, my surgeon who did my gastric sleeve weight loss surgery is really pleased with my progress and has signed off for me to have skin reduction surgery soon. Nice. That is yeah, it's good that you're recovering so well from that, Amanda. I'm really pleased to to hear that you're winning at life. That is very cool. As Pete just said, you're allowed to slow down a little. Yeah, 5 nerd brags on 1 week, that is too much. So slow down. Oh yeah, so Paul pointed out the pole sensor, which is right. I had it. I actually just moved it a moment ago. It's right here on the bench. This thing. This is what Paul sent me. So we are going to check this out. I am going to get to this, Paul. I promise. So Paul is going to be doing a talk about this, I believe, at Everything Open. Is that right? Something like that. There is some talk coming up where Paul is going to be discussing this, and he sent me one to check out in advance. Sneak preview. Oh, Michael says printer colors are C, M, Y, and K. Yeah. Cyan, magenta, yellow, and what is K? I can't remember. Yes, black, but I wanted to say cyan. Yeah, black. Oh, C is black? So that is just the level, the overall level of luminance, perhaps? Yeah. And Paul says the pulse sensor has a similar RGB/GRB LED. Tassie Bob is here as well. So, good morning. Oh, also, so, good morning to Tassie Bob. David Crisp is here, and Gavin Jackson. Gavin. So, C equals clear or white? I don't know. We're going to find out. Yeah, chrominance, suggested Andy for C. We'll find out. We'll have a look in the data sheet. Okay. Paul, another nerd brag. Yeah, we need nerd brags from people other than Amanda, who is just outdoing us all. So Paul's nerd brag is reprogrammed a Sonoff POW or POW Elite ESP32 device by soldering a header and detaching USB to serial board for the win. Excellent. So you got new firmware onto it. What firmware did you put on? Was it Testomatic or what's the old? Yeah, there are a few alternative firmwares for Sonoff type devices. Pete says a subtractive color. Ketamine. So David says the K is ketamine. Scott Peeler says, I hope it's dolphins. Douglas Adams would be stoked. Yeah. Yeah. I don't remember. I did look at this. Oh, K is key, which is black. Google to the rescue. Thanks, Michael, for sorting that out. Grant says, break from nerdiness this week. Oh, Paul. Okay, so Paul did the firmware update to ESP Home. Yeah, so ESP Home is one of the other big alternative firmwares to go onto IoT type devices. Very good. Okay, now, people, keep coming up with the nerd brags. But this is what I plan to do. So, a long time ago, when I was working on a Lego sorting machine, I got this. So I ordered some color sensors of different types. This was a few years ago. So this was at a point where I had an arrangement with a publisher to write a book about Lego and specifically Lego robotics and integrating electronics with it, like Arduino. It was basically Arduino plus Lego. Never ended up doing the book, but one of the projects that I wanted to do in the book was a Lego sorting machine, including detecting color. And so I had a color sensor sort of thing. Now doing it these days, of course, I'd probably just get a camera, point the camera at it, and do a bunch of machine learning. But this was many years ago, and the strategy then was to have the piece of Lego, whatever it is, be moving along on a conveyor belt and point a sensor at it and determine what the color is. So we could do color sorting using one of these. And I have not actually opened this in years to look at what they are. Okay, so it's an Adafruit. It's a 1334 is the part number. What is the sensor on it? TCS 34725 RGB sensor. Okay. So this is also a possible sensor. Now, what is with all of this color sensing malarkey anyway? Why am I looking at this? I'm just looking around for... okay, I'm going to go and grab something. I was not prepared enough to have brought this in with me, but I want to show you what I plan to do with this color sensing arrangement. And how this all fits into Testomatic. Oh, so it's a good thing that I didn't move Testomatic out of the way. So this is the test module for this board. So this board with the RGB LED, where is it? There. With the RGB LED on it, goes into this test module. So it fits in like that. And the test module has all of the fittings in it to flash the firmware and measure signals and various things on that board. So this slides into the Testomatic chassis. Now, one of the tests that we do is verifying that the LED works. And I want to automate that as part of the test process. So I want to make a color sensor now and link it to the tester. So that what the tester can then do is send a command to the board and tell it to make the LED, say, red, and then measure and see if it really is red, and then make it green and see if it really is green, etc. You get the idea. Now, when this is in the Testomatic, there is a pressure plate, which comes down on top of it. Which way around does it go? That way. So the pressure plate sits, it's on a little levery thing which comes down and it pushes down on the top of the PCB, and it applies pressure and holds it against the test pins. So that's how we get the contact while it's in the test jig. So my general plan, this is the cunning plan, my lord. I want to add a color sensor to the pressure plate with some kind of like a tube or a sleeve that fits down over the top of the LED. So this is going to come down and push on the top of the PCB and have a tube here with the sensor in it looking directly at the LED. And by putting some kind of a shroud around it and attaching it to the top pressure plate, we can block out light that is coming in around and only see the illumination of the LED. And then the test program, which is running on the tester, can turn the LED on different colors, read the colors, and verify, yes, it really is doing what it's supposed to do. That is my plan. So, how to achieve it? Mitchell! Mitchell is here! Funny thing is, Mitchell has now appeared. Hang on, I'm going to show you this. This is like a an Inception thing. I'm going to bring this up here and here. Look, Mitchell is here in Mitchell's thing. And I'll click Mitchell's name to move it down out of the list. So, Mitchell says you could use a fiber cable in a sleeve that sits on the top part in place, then run the fiber to the sensor. Yes, exactly. So now there is a, all right. There are many different approaches to this. And when you...
Mitchell is here. TTS can balk.
yeah, TTS can balk because its creator is here to fix it if it does. Now, there is another board. All right, I'm going to grab one to show you. So this is where Mitchell's fiber suggestion would come in. In fact, do I have one here? I may not even have one. I suspect that I don't have one assembled. Okay, I'll have a bare PCB. I've just got to grab one of these bare PCBs out. All right. And I'm dropping them, but you can't see me, so I'm going to pretend that didn't happen. And this has a whole row of LEDs. Okay, I'm going to show you an issue. Now, what we have here is a board. In fact, I'm going to zoom and focus. Let's see, zoom and get the focus right there. That focus looks good. It's going to jump out again in a moment, but you see that row of LEDs just there with labels next to it. And the camera goes bang. Okay, now these are current limiting resistors, and then these are LEDs. So this is a whole row of LEDs that are quite close to each other that show the state of different outputs. Now this board has test points all over the bottom, and I won't bother going and getting it, but I've got a test module for this board as well with pogo pins that contact all of these test points. So we can check two things. Well, we need to check two things. One is the actual state of the outputs. These are relays on here. So these LEDs show the state of the outputs that are being controlled by these relays. And there are test points under here for the relay outputs. So what we can do on the test unit already is measure the state of the outputs, like whether we've got a 12-volt signal coming out of it, because this is for like an automotive thing, and the outputs are switching 12 volts that go to solenoids and different external things. So we can measure the 12 volts coming out of the relay. What we can't check is whether the LEDs turn on, because the relay might fire and we get a valid signal coming out the connector, but the LED might have not been placed. It might have been placed on its side, which happens sometimes, particularly with LEDs. That almost never happens with resistors and capacitors, but LEDs, because of the way their profile works. So a surface mount LED is, if you look at it side on, it's got a flat thing and then it's got like a bulge like this. And because of the, in fact, let's turn it into a profile. Because of the shape of it, when the pick and place machine picks it up from the top of the bulge, like right on that area there. And most of the time, well, it's not like a tube this way, it's actually rounded over that way as well. So it's more like a bulge in the middle of the shape. So if the nozzle comes down and picks up the part from the center of this, what can happen is if the nozzle is even slightly off center, the part will roll because it is trying to, like, imagine that you came off center here and you were picking it up here. The vacuum will pull the part and it will end up twisted on the nozzle. So it ends up not sitting with the nozzle coming down and then the part dead flat. It can end up rolled around at a strange angle like that. So if the pickup point isn't spot on, or if the part has moved a little in the tape, you can end up with the part like that. And what then happens sometimes is the LED gets put down sideways. You can actually end up, this happens, it's not like a crazy, never seen it before thing. This happens quite regularly when you're putting down, like we go through reels of LEDs. And when you're putting down hundreds and hundreds of LEDs in a run, you will inevitably get a couple that don't sit flat and they end up sitting on their side on the PCB. So we visual inspect all of the boards, but still, sometimes you end up with an LED, sometimes they end up totally upside down, like they just get put upside down on the pad. Sometimes they're put down sideways. weird things can happen. So checking whether the LEDs turn on is something that we do manually. For this particular board, you can see all of the outputs here. What we do, the test procedure, is that we have the remote control that actually drives this board, because there's a radio receiver on this board. This is all controlled wirelessly. So what we do as part of the test procedure is we have the transmitter sitting there on the bench, and we go through the buttons, and you press 1, 2, 3, 4, 5, 6, 7, 8, and you verify as you press each button that the corresponding LED turns on, and then you go through them again, 1, 2, 3, 4, 5, and they all turn off in sequence. And that way you are visually, like the human operator is visually seeing that the LED is operating corresponding to pressing the channel button on the remote control. And so what Mitchell was talking about was fiber optics. Now you can see the pitch here is quite small. Like, look, see my finger here. Look how many LEDs there are in a tight little row. If I tried to put a sensor directly over each of those LEDs on some kind of a mechanism that came down from above, there just isn't physically room there. So the way to get around that is fiber optics. So if you have, I'm going to do some really dodgy drawing here. Imagine we have this PCB, and then I'm just trying to give you like a perspective view, and then we have a row of LEDs. So we're looking at the PCB in perspective here. What you can do is have a mechanism with a whole lot of optic fibers that bundle together, and they come out into some kind of a bracket that holds them with the correct spacing so that they come down on top of each of these LEDs. And that bundle of optic fiber goes off to a series of sensors. So each one of those fibers terminates on a board with a sensor that detects what is going on right here. And you can do things like measure the level of luminance and the color, so the wavelength that's coming off it, just in case something. Okay, here's a scenario, because I've actually seen this happen. Sometimes, this is rare, but I'm talking about real statistical outliers here. This is oddball stuff, but the oddball stuff can still happen if you are dealing in enough volume. Imagine you have a combination of LED colors. You've got some red, some green, some blue LEDs on your board that you're assembling. And you pick up a red LED and it fails for whatever reason. Say it jams on the nozzle, it gets put down on the board and then lifted, and it stays stuck to the nozzle. And then you pick up a green LED, but you still have the red LED stuck on the nozzle, so the green LED fails to pick up, and then the machine puts the red LED in the place where the green LED was meant to be. Yes, I know, that sounds ridiculous. But that's just the reality of manufacturing. These things that you would not predict would happen, and leave you scratching your head, because you end up with a red LED where a green LED was meant to be, and you think, how the hell did that even happen? I don't understand. But weird things happen. Yeah, and there are interlocks and things like pressure sensors in the pick and place machine to detect if there is a part on the nozzle and whether it's been dispensed properly. And you can do things like optical checks after placement to make sure that the nozzle is clear, but that slows down your process, so that's not generally done. So there are all sorts of additional interlocks and things that can be done to reduce those 1 in 10,000 sort of events. But when you are placing thousands and thousands of parts in a run, ooh, what was that notification? I missed it. Something just popped up on my on my wrist, on my watch, and I missed the notification. So those things happen. These are the sorts of oddball situations that I'm trying to catch with this test system so that we can put boards into the test system and know that when they come out, all of these things have been checked. So, yeah, this optic fiber cable, this is very commonly the way to do it. If you, there is a whole industry around test jigs. There are things that you can buy. In fact, let me see what I can find. If we come back over to here, I'm just going to do a search for a test jig, LED tester. I'm test jig LED. No. LED tester module. No. I'm not even quite sure what keywords to look for here. I'm just doing a bit of a quick search. No. Oh, test up to... No, is that it? Oh, I think so. Yes. Yes, this. Okay. This is the sort of thing. Now, test up to 254 LEDs with a single USB cable or RS-232 cable. This is the sort of thing that is used when you're building a like a high-end test jig with lots of LEDs. So daisy chain, you can daisy chain them. It's got 18-inch or 24-inch fibers with custom heads. Fibers come with the module, and what you can see here is it's got these 16 inputs on the module, and then each one of those has a piece of optic fiber coming out of it, and you can see here in this picture they terminate on a little polished end of the optic fiber. And so when you product pricing, I'm curious to know, it's probably crazy pricing. Let's just say, where are we? 12 mod? I don't know, quantity 1. Yeah, request a quote. This is one of those classic things of, if you have to ask the price, you can't afford it. It's like going into a high-end car sales place and there are no prices because unless you have a private jet, you probably can't afford one of their cars. So yes, these things exist, and what I'm trying to do here is have something that is like a low-end functional equivalent. This is the sort of the dream device. And what you do is you build this module, like you attach this module to your test chassis and then connect it to the test runner by USB or serial, and then you route those optic fibers into some kind of a custom-made carrier that has them terminating at exactly the right
Mitchell
place.
Manor said, look at standard fiber patch leads. Since you don't need distance, it should be cheap and easy.
Ooh, fiber patch leads. Yeah. Yes. So I do intend to look at, not that you can tell much from that picture. Yes. Also, did anybody, I'm sure there are some people here who realize that I own fiberoptics.com. Just for the fun of it. I did some work many years ago for a company that does fiber optic test equipment, as in the equipment that tests fiber optic cables, and they make the gear that's used by factories and and different places to test the characteristics and performance of fiber optic cables. And I won't go into the whole history of it now, but the end result was somehow I came out of that project owning the domain fiberoptics.com. So, yeah, I actually still own fiberoptics.com. So, you can buy chunks of fiber optic cable of all sorts of different types. And ultimately, that is what I want to do. So, the way I envisage this is the very first step is to build a single channel sensing device with the minimum possible mechanical complication. I want the MVP, the minimum viable product. So the way I see this, the minimum viable product is...
At Tinker001 said, that's almost as good as owning borg.ca.
Yeah, that one is a classic. Good one, Tinker. Oh, Mitchell has a thing to say using Mitchell's
At
TTS.
Mitchell Manor said, just tested with a fiber patch lead that is 2 meters long. It does work.
Yes. Yeah, and that is exactly where I want to go. But this is my sequence. Step the first is to get a single I2C color sensor, be able to communicate with it and read from it. And then make up some kind of a mechanical mount that allows me to use it. So the simplest case is exactly this. It is a 5mm through-hole LED. It's huge. It's tubular, which means I can fit a cover down over it to block off all external light. It doesn't have any other parts near it, like there are no other light sources near it, so I don't need to distinguish between LEDs that are very close to each other. Like, this is the perfect, simplest possible case for me to measure. And it is an RGB LED, which means that it also gives me the opportunity of measuring not just is the LED on or off, but what color is it currently displaying. So my plan is to make a sensor that solves this problem. And then the next stage beyond that is to make that same sensor mounted remotely with a piece of optic fiber. And then the next step beyond that is something similar to this, where you have an array of sensors on a board and you can have multiple optic fibers going into it, so that then I can test boards like this, which have a whole row of LEDs next to each other. That is the ultimate goal of where I'm going with this. But I am not going to try jumping straight to the end result of a multi-sensor array with optic fiber when I can just do the first stage, which is one sensor, one LED, and no optic fiber. Yeah, Pete, my face is the simplest case. Hang on. There have been a couple of things blocked. So Grant says, can you implement this on one of your little modules? That was blocked. Oh, not a model supporter. Okay, it's in
Can you implement this on one of your little modules?
It's in a supporter mode. And yeah, that's the idea. Step one is to make this like a little thing. Oh, in terms of form factor, yes, we'll get there. We'll get there. And
your face is the simplest case.
Yeah, that one was blocked by the bad word detector. Which reminds me, Mitchell, last week... Oh, okay. So another thing Pete said earlier, I'm going to manually hit it now.
C equals clear, white.
Yeah, that was blocked by the bad word detector. So last week, Mitchell, I don't think you were here, we were having issues where just about everything that anybody said was blocked and it said bad word detected. And it, even on things like nothing but the word test, and it would say bad word detected. Yeah, as Michael says, last week all words were bad. uh, oh, that's right. Yeah, Pete said balls, and that worked. Yeah, so it refused to say the word test, and it said that was a bad word, but Pete put in balls, and it said that. Um, ooh, this is an interesting idea. Tijra said, can you not use a linear array that are used in scanners, plenty of them around, and use it to sense as many LEDs as you like? That is an interesting idea. Hang on, let's see if this works. No, it's not going to say that. Blocked, bad word detected. Pete saying your face is a bad work.
Bad word detected.
Bad word detected. It says bad word detected. Thanks, Henrik. Okay, so having joined the chat, we have Tidra, and Henrik is here, and Stephen is here. Welcome. That is a very interesting idea. Using a linear array, and then you could put a bunch. Well, a couple of things. Depending on the physical size of the array, you could put the array actually right down on the thing. Oh, and the other thing, of course, is cameras. Yes. So one of the things that I have thought about is, why not just point a camera at the board and then use image processing to detect whether the LEDs are turned on or off and whether they are the correct color. That is, yeah, I have seriously thought about that. That is an interesting way of doing it as well. So there are a couple of things to keep in mind. One is alignment. It would have to be very accurately reproducible. I think it would be more prone to issues with ambient lighting. So we'd need to block the test jig off a bit more so that you wouldn't get different reflections and things off the board.
At Amanda_RFT said, it was the YouTube long username. I started with user Amanda_Thompson_68 and did not work, but with Amanda_RFT and the username, it works.
Yeah, that's true. I think it was Crispian who worked out that his long username was causing everything to be blocked. Tijra said they are much more sensitive and probably do more in the long run for different modules. That's true. And yeah, and as Mitchell says, that's why I said fiber. It's so thin you can batch like 14 together and it's less than 5 millimeters. So you can run all the different LED fibers come together to a single sensor. Yeah. So that gives us some options. This is all future planning now. What I don't want is to bite off a big complicated project that becomes insurmountable. I need to break this down into quick wins and deal with making something that is useful as immediately as possible, even if it doesn't do everything, and then progressively expand it to do more, make it better. And so that is my plan. So my plan is, first step, get a single color sensor, wire it to I2C, communicate with it, and oh, sorry, I just saw a notification on my phone, which might be, okay, Hugh, if you're watching the stream, no, there is no barbecue today. Barbecues are only every second month. So I'm going to have to reply to him afterwards. Hopefully he doesn't make a trip for a barbecue that doesn't happen. Ding, says Pete. Yes. Henrik says, you need a black box for the camera trick. Let's say the color is right, but the brightness is way off. You can't detect it without darkness. Yeah. Yes, you can use cameras.
Black box for the camera trick. Let's say the color is right, but the brightness is way off. You can't detect it without darkness.
Yeah, I shouldn't have read out the thing that TTS was going to read anyway. Tidra said, yes, you can use cameras also, and alignment is a non-issue as you can use open source optical analysis code. Yep. So the other issue is just the mechanical aspect. I'm trying to find how to, okay, let's see. This is not going to be a great example because it's not that board, but I don't have the test jig for the other board here. If I'll go to the overhead camera because I think I can show you here. Oh, now we're zoomed way too far in. I need remote control of the zoom for this. Okay, so this is the test module with the board in it. The LED is there, and this is the pressure plate that sits down on top of it. You are looking directly down right now. You are seeing this from above, and you can see the LED is there. But when this is in the test jig, in fact the test jig is right here, this pressure plate snaps magnetically. It's actually running, so I've got to be a little bit careful. It snaps magnetically in there, and then the board would be down here, and this lever pushes the pressure plate down. So there's a question of where does the camera go, because you've got all of this structure right here, and it's part of the board is obscured by this. You've got pressure pins. So the options are to either mount the camera up on the body of the tester, looking down, and then parts of the board will be obscured by the structure of the pressure plate, or mount a camera on the pressure plate, which puts it very, very close. So you'd have like that's 30 millimeters. These pins are 30 millimeters long. So the camera would need to focus 30 millimeters to the surface of the board when it's pressing down on it, and then have a cable coming up. So there are, yeah, all of these things are potential solutions, but there are just these little complications along the way. And so, yeah, I'm gonna have to try different things, but my I'm going to move that into there, dock that, and have a look at this. So, but I don't want to be derailed by trying to solve the ultimate totally flexible cover all scenarios option and have me
What
then...
sort of camera should it be then?
I don't know. Tidra said hole through the acrylic and camera on the opposite side. Yeah, potentially. But it depends how the LEDs are distributed across the board, because you might have a board, like in the case of this board, where are the LEDs? There's a row of LEDs there. Oops. There's a row of LEDs there. There's an LED there. There's an LED all the way over there. So diagonally opposite corners of the board, which means that you've got to have field of view of the entire board, including the pressure assembly, which is right in the middle. So, yeah, it could work, but there are complications, and each board that you're testing is going to be its own unique snowflake with its weird locations for things. And that is really where things like these modules work so well, because it doesn't matter where on the board the LEDs are. You have your test module, and then you have the different fibers that just route through the pressure plate to different locations. And you can put each one exactly where you want it to be, anywhere on the board. And you can get numbers out of them. That's the other thing with this is, with this, the idea is that we're going to get actual numbers, and we can define thresholds. So we could say, for example, like I'm just going to make up units here. We'd actually be talking about levels of illumination, but forget units, just talk numbers. Say we've got an output for each wavelength on this sensor of 0 to 1024. Now, what did it say it was? Was it 12-bit, 16-bit? Whatever, doesn't matter. Let's just pretend it's 1024. So what we could do is, if the sensor, say there is total darkness at 0, and if the sensor is fully overwhelmed by the level of illumination, like maximum it can read is 1023. And so what you might say is that an acceptable brightness for this LED might be between the ranges of 450 and 650, somewhere in that range. And so what we can do in the test script is have it read the level of luminance coming off the LED in that particular wavelength and see whether it's within that range. Because what this allows you to do is things like pick up a situation where the wrong resistor, like the wrong current limiting resistor, has been put in place and the LED is too bright or too dim. It might be turning on, but it might be turning on really bright, or it might be turning on and being dim. So you might be able to detect that the LED is on, but it is not in an acceptable brightness range. And that can also, so this is part of a quality assurance thing.
Tinker001 said, if it gets 1024, tester outputs Chinese LED.
Yes, the burn your retina style. There was a question, are the sensors logarithmic or linear? Asked Grant. I have no idea. All I did was find a sensor that looked like it was in a package that kind of made sense. Hang on, I've got a cough again. And had some drivers supporting it. Seemed to have the features I want. So this is a first pass of trying to find a sensor that seems like it'll be suitable. It may turn out that this one is not. But what you're seeing here is me learning. Because, oh, here we go, 16-bit resolution, 2 bytes. So I've never used this sensor before. I don't know how well it works. I've not seen it. Like, I've looked at this and I've thought 3 millimeters by 1.5 millimeters, that seems in the ballpark of being small enough that you can get it into small spaces and big enough that it is not ridiculously hard to work with. It's not like a 1 millimeter by 1 millimeter sensor with 4 pads under it. That would that would break my mind. And also, it seems to be designed so that you can either mount it. So you can see these pads are on the corner here, which means it should be possible to put it down either vertically so that it's sensing directly axially to the PCB, or on its side so that you could have like an edge detection arrangement depending on how it's going to be physically mounted. So there are some options here, a bit of flexibility. I don't know if it's actually even meant to be used that way. Here we go. Recommended footprint, package edge to edge. But yeah, it seems like it could be done either way if I really wanted to. So, where are we at? 11:05. Now, what am I looking for? What am I looking for? Okay, so this is a 3.3 volt sensor. My very vague plan here is that just before the stream, I grabbed out this container, SparkFun Quick. So I've got cables and things in here. What have I got? Connectors. Actually, this is a box from several years ago. I don't even know what's in here. So I've got some quick cables, short ones, long ones, medium ones. These are quick connectors that break out to pins. What's this for? Photon I2C shield. Okay, so this is a, oh, that's got some quick connectors on it. Here are some surface mount sockets. And what is this? Quick pie hat. Oh, okay, so this goes onto, like seriously, I ordered this stuff years ago, shoved it in here, never even opened the packet because it looked like it would be useful, and its time has come. So with this we can plug it into a Raspberry Pi, and then we can plug things in there. What else have we got? Are these more the same? Okay, now these are Arduino shields with quick connectors on them. So for those of you who don't know what I'm talking about, quick is SparkFun's term for an I2C connector in a kind of generic format, and Adafruit have the what's it called? Someone in the chat tell me what's Adafruit's equivalent. I can't remember. So my idea was to get a quick connector and just solder it directly onto the sensor. Maybe one of these, because these have got pins coming off them. I'll take one of these and solder this directly onto the sensor so that I can then plug the sensor into one of these breakouts and then try reading from it. That is my cunning plan, such as it is. Yeah, so there are some connectors there. Stemmer, yeah, that's it. So Adafruit call it Stemmer, and SparkFun call it Quick. And I think they're compatible, like same connectors, same signals, etc. I'm not quite sure what the difference is apart from their branding. And they define them slightly differently, but they're effectively the same thing. So I think I might even have somewhere around I might have a box that is Adafruit Stemmer stuff, and I should just chuck them together because they do the same thing. All right, now I need to find out what the connections are on this.
And Railwaytep said, "Are we there yet?"
Yeah, we're almost there, Pete. And then put it on the little sensor, and the sensor is in here. And whoop, yep, it's dry. That's good to know. It's getting a bit jammed up on the bench here. It's very tight with everything. Everything is encroaching. Like the area that you can see in the camera, from there to there, like that amount of the bench, just outside of camera view, it is jammed up. There is stuff piled up around me, getting in the way. Okay, I'll just get the microscope close, because I'm going to chuck one of these under the microscope and see what they look like. See if they look anything like the diagram in the data sheet. And I think I will be able to show you. Oh, come on. These are dodgy tweezers. These are my my messed up ones that I use for rework. So the tips are bent and they've got flux on them and stuff. I keep those. That's why they have the red marking on them, because they're the dirty tweezers as opposed to the good clean tweezers. All right, let's. Oh, they actually put them sideways in the tape, so it looks like they are designed to be side mounted. I will switch to that, and oh, it fell out. Which way was it? There's the sensor. Get some focus happening. There we go. So that is the top of the sensor. I'll tip it on its side, and you can see the little castellated mounting points on there. Now, if I am super lucky, the order of those connections will match the order of, actually it doesn't really matter, but I was thinking of soldering a socket directly onto this and just sort of bending the pins a little bit. So if a stemma / quick connector is in that same order, then it's a direct 1-to-1 ratio. So yeah, they are quite small. Like, there's my finger for reference. 1.5 millimeters by 3 millimeters. So they're small but not ridiculous. They're within the realm of not too bad to work with. Oh, you can see how dirty these tweezers are there. You can see the flux on the tweezers and the bent end on it. Oh, actually the flux is what's holding the ends apart. Okay, I'm going to clean that off. Did I get it off? Can't really tell. Nope, still there. Okay. That means that it is scalpel time. Got to get that flux off. And I'll clean this side as well, just in case. And now do the tweezers close? Yeah, better. Slightly happier. All right. So here we have...
At Tinker001 said 1 millimeter pin spacing.
Yes. So 1 millimeter pin spacing on the sensor or 1 millimeter pin spacing on the connector. Let's do ourselves a little comparison. So we've got, where is the pinout? I'm going to find the pinouts, just leave that on the screen. Oh, come on. Okay, here we go. Pin assignment is there. Now I'm going to do quick connector pinout, which is SCL SDA 3v3 ground. What have we got here? SCL SDA, ground and 3.3 volts are swapped. That's a pity. Oh well. I can do it with flying leads though, so that works out alright. Okay, so the pitch, yeah, it's approximately a millimeter. It's 1.02 millimeters between these inner two pads and then 0.965 millimeters from that pad to the edge. So give or take 1 millimeter pitch approximately. And the stemma connector I think is 1 millimeter pitch, the quick connector. But it doesn't matter. It doesn't match. So what I had been thinking of doing was getting one of these connectors, which is the quick / stemma connector, and you can see here it's got these pins. If the order had been the same, my plan was to get this connector.
At Tinker001 said 0.02 millimeters is within error.
Yeah. Yeah, that's right. So I was just going to get the sensor and solder it directly to the socket so I could then just make it pluggable. However, that is not going to work because the order is not quite the same. We've got ground 3.3 volt SDA SCL, and over here we have 3.3 volts ground SDA SCL. So ground and 3.3 volts are swapped relative to each other. No problem. I can work with that by connecting the cable directly. Let's see what the dealio is here. So what we have is, in a total shocking turn of events, ground is black, VCC is red, and then we've got SDA is blue, SCL is yellow. So I think it's time to turn on the soldering iron and cut some wires and do some soldering. Yeah, why not? Why not? Yeah, what's the why not? For some reason, it makes me think of Lord of the Rings. Was it Smeagol who said, why not? No, no. I think it might have been... Oh, I can't remember. It was something to do with the ring, though, and keeping the ring. Hugh has messaged me again via a different mechanism. Hang on, I just need to reply and tell him. Hang on. Let's see. Hang on. Where is the notification? Sorry to interrupt your regularly scheduled programming. I'm live streaming until 12-ish. Okay. Then... So
I'm turning on the pan to solder some meat onto a burger.
you're turning on...
At Tinker001 said, you could wire it up like the test set I DM'd you last week.
Wire it up like the test set. What was that test set last week, Tinker? I need to... Hang on. Do I have Discord open? I believe I do. Let's see. Where is the test set? The test set? Oh, come on. Why can't I select... I dislike... Oh, come on. I dislike the UI trend towards having zero width borders on windows, which means you can't grab the border and resize it. It's so annoying. They need handles in the corners. So, Testomatic Junior. Oh. Okay. I don't think I'd actually seen this message. Was week before last, says Tinker. Test set. The hardware. Oh, okay. So, stuff hanging out everywhere. Please excuse me, everybody else, while I have a quick look at Tinker's test setup here. Solder paste, stencil, 100 by 100. Interesting. Okay. Scroll up a couple. Okay. There was a Menzi Mark M545 Extreme. There's there are Ethernet cables. So I think this may be, hang on, I'm going to see if I can bring this up on screen without it revealing the whole chat. So is this the one you were referring to? That is pretty much how this is going to be wired up, yes. Okay, so back to here. I'm going to cut these off. Here we go. Point of no return. Okay, they're done now. And time to... come on. I'm feeling very clumsy today. My fingers aren't working the way they're meant to. No comments, Pete. I'm expecting Pete to have some kind of a rude comment about that. And got to turn on the soldering iron. That does help. Now, where's my solder? I've got stuff everywhere. I need to clean up. Need a little bit of solder. I don't even know what it is. It's a short length. Don't know if it's leaded, unleaded, special, like, It's just a random little length of solder that happened to be sitting on my bench. Okay. I still have both leaded and unleaded solder around the place. So we're, when I say we, I mean me and Tom, are in the transition to being as unleaded as we can. So using unleaded solder everywhere we possibly can. But there are still, it's still a mix. We're in that transition period. Which one didn't I get? Oh, red. Red has not yet been tinned. Okay. Now, how am I going to do this? I think I'm going to need maybe a little bit of blue tack to hold the sensor down while I attach the wires to it. I'll work something out. And that way. I also need to figure out which way, yeah, I think I can work out which way around the thing goes. Let's do some, okay, step one. I'm going to stick this sensor in a piece of blue tack and then attach it under the microscope where it's in the field of view. I think that is about right. Leaded equals regular Coke, unleaded equals Diet Coke. Yeah.
I suggest get an assistant like Apprentice or something to help you out with the stuff.
Oh, I kind of do have that. I have my son, but he's not here. He doesn't come in for live streams. What am I looking for? I'm looking for the microscope view, which is that one. Okay. So, step one, I am going to just tin these connections. Now, I think this soldering iron tip might be a little large for this, but let's give it a shot. Tin, 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 tin. Yeah, I think that's worked okay. I could switch to a smaller soldering iron tip, but it doesn't really matter. Now, I need to figure out from here which one is which. And I think I'll do the two inner connections first. So pins 2 and 3. So we've got ground and SDA. So I want black and then SDA according to, let's bring this up here. SDA according to this is blue. So I want black, black and blue connected onto there. I'll zoom this in more just because I can. Black and then blue. All right. This is where I find out whether the, oh, get out of the way. Whether the wires are too thick for this purpose. Now, this is, you should appreciate what I'm doing for you here, because the microscope, when it is focused on the microscope, when it is focused on the camera, is out of focus in the eyepieces. So when I'm trying to do this with the microscope, it's actually just a blur. You can see it on the camera. I'm just seeing a bit of a blur. But if I focus it for myself, you won't be able to see it properly. Okay, so we've got ground, and then we need power up to the top pad, which is on the corner. Oh, stay there, stay there. On the corner of the sensor. So there. And then SCL, I think it is. Yes, SCL is yellow, goes to the opposite corner of the sensor. Come on, get in there. There. I think that's... to be able to tell if I've done a proper job, I'm going to have to defocus it for you. All right. Let's check this. Yeah, it's okay. Now, the yellow one is a little bit sus.
001 said, melt that insulation.
Yep, melt it. Melt it good. I'm going to resolder that yellow one because I am not totally satisfied. I think that's okay. Just making sure there's no... Well, it looks like there's a bridge between them. No, now there's not. I think there was a little sliver of solder just there. I think we are safe. Now, one thing I don't know is how sensitive these are. What would be really bad is if these sensors, with their clear encapsulation on top, are as sensitive to moisture and other things as the LEDs that have given me so much grief. But hopefully they're okay. But it does remind me, I'm going to put them back in the bag with the desiccant and stuff and close it up. Yeah, in the time it's been sitting on the bench, hang on, I'm going to put this under the microscope. This is the moisture card. So 60% is still that, 10% has changed color, and 5% has changed color. So yes, in the time that it's been sitting here, in those few minutes, it has started absorbing moisture. I'm going to seal them back up in the bag. Okay, now we need to work out what the deal is with drivers for these things. And what can I use? There is a Raspberry Pi. Yeah, okay. I think I'm going to try to do it off a Pi rather than an Arduino because I have a Pi. Let's I'm going to do a bit of a quick driver search. So it is, oh, what's this sensor called? VEML, EML, Python driver. Okay, what do we have here? Arduino library. Oh, that's an Arduino library. I want a Python library. Please refer to the datasheet. Oh, pull-ups. Yeah, do I need to put some pull-ups on this thing? Or are they already on the breakout? Okay, so that's an Arduino library for it. CircuitPython library for this. Don't need a library. Just, okay, so that is, let's just say Raspberry Pi and see if anybody else has done it. AI is going to save us and tell us how to do it. Yeah, side view package. Oh, okay, SL indicates side view package. Hardware connection to Raspberry Pi. Yeah, okay. Do that. I2C tools, I2C detect. Yeah, okay, so it appears as hex 10. Well, that sucks because that address is used by there's something else in Testomatic that uses hex 10. I think it's the AD5593R. Ooh, all right, we might have some complications to deal with here. Hang on. Johnny, why didn't TTS say anything about that? Is TTS behind? 130. Because Johnny just did a member for 38 months. 38 months? AM or PM, and TTS missed it entirely. Huh. Yeah, okay. It doesn't even appear. Like in the UI in here. So, Johnny and Dodgy, welcome to the chat. See, in here, the 38-month membership just doesn't appear. It should be, and Pete's just 31 months membership. So, after Tinker saying, here's Johnny, where was it? This is... Oh, okay. So that is, thanks Pete, 31 months of membership, but there are messages missing from the chat. Morning Johnny was Dodgy right there, and 4 out of 5 are pass. There are 2 messages missing in the middle there, including the including Johnny's membership. It's just skipped them for some reason. It missed the membership message, and it missed the another just regular text message. Henrik. Invisible bad words. No, the thing is that even when there are bad... Pete, you're going? The thing is... Yes. Super chat. Where you at? Let the party go. Lights up, feel clap in this awesome show. So the thing is that even if it blocks it, the message should appear in the user interface here for the management interface. So anyway, it just hasn't picked it up for some reason. Tassie Bob, months is a bad word. Yeah, it could be. Tassie Bob, you're a bad word. Okay, we'll see if it picks up Tassie Bob's membership. Yeah. What am I doing? That's right, okay. Oh, we got Tassie Bob's membership. Thanks, Tassie. That can be on behalf of Johnny's membership as well. So, import that. Def read color, basic initialization. Oh, Henrik is always tormenting me with descriptions of food.
The tasty handmade burger is so ready now.
Yeah. While I am trying to stream and trying to keep myself on track and ignore the fact that my stomach is saying it's nearly lunchtime, you just torment me. Okay, so what are we doing? A bus read on address 567. We've got... Is it really that simple? Seriously? Is it that simple that we can just read those registers and get the values? I hope so. In which case, thanks AI. Okay, so I have a Raspberry Pi sitting here off to the side, which is it's a really old Pi. It's a Pi, where are we? I've got to look it up. Is it a Pi 3? It's a Model Pi B Plus V1.2 Raspberry. Yeah, 2014. It's an 11-year-old Raspberry Pi. So what I'm going to do is, but it does actually have an OS on it and not much else. So what I'm going to do is, I'm going to take this quick breakout and stick it on. So, can I move this? No, it's connected to a, it's turned off right now, but it is connected to a, oh, that's annoying. That means I can't connect power properly. How am I going to do this? Maybe some dodgy alligator clips. I need to get 5 volts onto it. So I'm going to take my little sensor and plug it into one of these sockets on the Pi hat breakout thingamajigamy. And so what have we got here? SparkFun Quick. Is that 5 volts or 3.3? Okay, 3.3 volt I2C ports. That's what I want. Yes, yes. Don't want to nuke this little thing. Now what do I need? Oh, now I need some alligator leads off my lab power supply, which I'm going to set to 5 volts before I connect anything. Set a 2 amp current limit. Okay. It's unfortunate that you can't actually see the Pi, but it is plugged into an HDMI cable. And where is ground? Okay, I've got to check the label. Does the label tell me? No, label does not tell me. I've got to check the Raspberry Pi pinout. That'll do. Okay, so top 2 is 5 volts and the third one down is ground. It's plugged into an HDMI cable, which is plugged into the 8M, which means we can capture the output from it, which might actually be useful. Okay. Now, power on. I did not see a bang, but if we go to camera 6, we, in a second, will see, maybe, come on. I saw just for a second the Pi booting up. Right now, black screen and my voice. Yes, here we go. Welcome to the Raspberry Pi desktop. And I am also going to get a shell on it once it comes up. What is this Pi called? What's the host name? Maybe we'll see it. SSH. Oh, screen 1, I think is what I called it. But I'm not going to be able to SSH into it until it's finished booting. And because it is such an old Pi, it is going to take a little while to boot up. Let's see if this breaks the internet. No, it doesn't. Managed to turn it on without breaking things. 2011 Pi should only take 15 minutes to boot. Yeah. Okay, so current scenario is I have a Pi which is running Raspbian, or Raspberry Pi OS as they prefer it to be called now. You're running a 32-bit OS. Yes, because it is a Pi B. Like, it's old. This is an 11-year-old Raspberry Pi. It just happened to be on the bench, and I was trying to do something with it a couple of days ago, which is why it was still here. So I've plugged in the Pi hat, which gives which has quick connectors on it and a voltage regulator. And the sensor is currently plugged into that. So we shall see what happens. I suspect this is going to come up to a desktop at some point, eventually. In the meantime, I am going to try SSHing into it, because it may actually be on the network by now. It may, or it may not. Patience, grasshopper. Patience. And soon we will get, let's see, can I do that? Yes, I can. Which, once again, you can't see. Oh, Tinker says, my only currently operational Apple product uses an 8-bit OS. Is it an Apple IIe? Because even the very early Macs, I believe, were a 16-bit OS. This really is taking a long time to boot. An epically long time to boot. 2 plus. Ooh, an Apple 2 Plus. Very nice. 12 o'clock are for people without enough numbers. And as Johnny says, we have 24 hours here, just like you all, but we use them in order. Yeah. Army time. Come on. All right, what I am waiting for right now is for this thing to come up on the network. Why is it not showing any network connection? Has it not? Come on, surely. Yeah, so the LEDs have not come on the network cable. I wonder if the network cable has fallen out under the bench. Okay, so Scott says, while we're in intermission, enjoy this bit of knowledge. I was thinking a moment ago, is Australia about the other side of the world from Oregon, USA? So I asked AI, and this is what she said. Yes, Australia is essentially on the other side of the world from Oregon, as their positions are nearly antipodal, directly opposite on the globe. This has not come up on the network, and I don't know why. So, in order to do anything with this, I would need a... This is going to be annoying, isn't it? I need a keyboard. All right, here we go. I am going to steal the keyboard dongle out of the Testomatic. Oh, that's the Microsoft dongle. Where is the keyboard dongle for... is it that one? No, that's the Space Mouse dongle. I have another keyboard here, this one, and a mouse that matches it. And somewhere there is the dongle that goes with them. And I don't actually know what computer they are plugged into right at this moment. So if I start typing on this, some random computer is going to start responding. Oh, I think I have an idea.
Not any teasing sorry about it, but question when fried egg, little runny yolk or firm yolk?
Henrik, that depends on whether there is bread. If there is toast or something to mop it up with, I would go for a slightly runny yolk. Now, maybe... Oh yes, I think this... No, that's the dongle for the... yeah, that's so annoying. I have lost the dongle for that keyboard. It will be here somewhere, plugged into a computer. All right. I have here my old Microsoft Sculpt keyboard, and that, I believe, is what this dongle is for. So I'm going to plug this dongle in, and I'll see if I can do anything useful on this Pi. I've got to plug it in without bumping the dodgy power leads. Now, let's see what happens. Is it working? Nope. I wonder if this keyboard even has power these days. It's probably a couple of months since I've used it. I can't even tell because there's no power LED or anything on it. Well, this is annoying. I just wish I could find the dongle for this other keyboard. Because then...
Amanda_RFT said, is TTS working?
It is indeed. It is indeed. Where did that dongle go? And what is that dongle? Oh no, that'll be for my trackball perhaps? Let's see, what is this one? It is a totally unlabeled dongle. That is particularly annoying. Yeah, when you get dongles and they don't say what device they are for. If networking was working on that Pi, we would not have a problem. Okay. How else can we do this? I'm thinking of, I've got a couple of ideas in mind, but they all seem like kind of ridiculous ideas. I'm going to jump under the bench. Oh, I know why the network isn't working. I totally remember now. Oh, okay. I'm now lying on my back under the workbench. I am short one Ethernet port on the switch that's under my bench, and I plugged in. Let's see if this brings up networking. See if it comes to life. I plugged in my Rigol scope. Come on, wake up. Yeah, I plugged in my Rigol scope a couple of days ago because I wanted to. Oh, I've got to get back out from under the bench. Oh, yes, I think the network is up. It is. It is. We are saved. Now, what is the password? Is that it? Maybe. And what was I talking about? That's right. I was trying to screen capture off my Rigol scope. So I plugged in the network cable from the scope and I unplugged the Pi's flying lead in order to do it. Okay, we are now up. Let's see, Raspi config. Let's just make sure that I2C is turned on. Interface options, I2C. We want yes, I2C to be turned on. And we will reboot. Sorry, folks. Sadly, I must reboot, which means it's going to take a while because I don't think I2C enables unless it was turned on when the machine boots. So, Tinker says time for a 48 port desktop switch. Yeah. Michael says, I'm thinking you have a layer 1 networking issue. Yes, definitely. It was indeed a layer 1 networking issue. Now from here, yeah, the Pi is booting again. Okay. Where I'm hoping we're going to get to, I think we're actually really, really close. We should be able to, assuming that we trust our AI overlords, use this and get some values. And if we do, I will be very happy because that is so simple. So we're just saying, so we're doing the bus and then we're reading a word from address hex 10 and 5, 6 and 7 are the registers. So there must be 2-byte registers. I'm not entirely sure that I trust this, but if it works, that's kind of funky. So register address, yeah.
You need the so-called internet splitter that unfortunately doesn't work.
The internet splitter. Yeah, is that the thing where you've got a couple of RJ45 connectors that are just sort of connected together? Tinker says, I'd offer one of my spares, but shipping would suck. Yeah, it would suck. Shipping from the other side of the world. I'm just paying attention to what's going on the Pi. It looks like I can't actually read it. I'm capturing HDMI into it, and I'm seeing a little preview. I can't read what's on the preview though. But let's just try doing this and see if we can get a shell on it. Oh, no, it hasn't quite got the the desktop up yet. We should be almost there. Yes, we're almost there. Let's see. It's being very laggy because it's a little old processor running as fast as its little silicon legs can take it, which is not very fast. It's really sad that these old Pis aren't that useful. What I was really wanting to do, the reason that it is set up, yeah, look at the load as it tries to do its thing. What's it doing? Pac-Man, libxec, yeah. It's running through all sorts of just its normal cleanup sort of stuff. Yeah, the load is now falling 8.82. It's going to come down as the kernel catches up with all of the things that are on its little to-do list.
Tinker001 said, silly little Pi takes nearly as long to boot as a server.
So do I2C detect -Y1. Let's see what we've got here. Oh, look how slow that is. What? Really? Oh, this might be. Oh, I wonder if this is a Pi that is so old. Yeah, oh no, it is. It is bus 1. That is disturbing. And also we don't have, so for reference, when you do an I2C scan like this, this should go zip and all done. The fact that this is taking like 1 second for every, maybe it's just like a really long timeout. But also the other thing that's disturbing about this is that there should have been a device at hex 10, I think. All right, while that is doing its thing, let's go and have a look at the data sheet and see what it says about the I2C address. I2C address. Addressing 7, okay, uses 0x7 for 7-bit protocols, okay. Let's see what the registers are in here while I'm waiting for that thing to run. Michael says, Pi 5s rock. Yeah, except they're very expensive and they run hot. So...
At Tinker001 said, might have been better off setting up AD1 Mini.
Yeah, I think I might have been. But I really do want to get this running with Python as well. That is a factor here. But what I might need to do is plug this into the Testomatic chassis and do, because that at least is running properly. It's a Pi, this one, the Tester 3, that's got a Pi 4 in it. So it's significantly faster. Okay, now, where are we? Data registers. This, okay, so registers 5, 6, 7 are red, green, blue, which means I don't think AI was lying to us in this particular instance. But sadly, look at this. It has not found the, I'm just going to run it again. It has not found the device at address 10.
Is the wiring 100 correct?
Probably not, Henrik. Let's do a quick check. Okay, so on the quick connection, ground is black, power is red, SDA is blue, SCL is yellow. All right, now on here we have, what I should have, just based on the orientation of the way I was soldering onto it, it should go red, black. I'm going to get both of these on the screen at the same time, just for the sake of being able to not rely on memory. So we have, oh come on, over there. And then, oh come on, stop resizing the window, you stupid OS. So then we have, for the pink LED fund. Yes, that's what I'm about to do, Tinker. Tinker said, well, TTS should catch this up in just a second.
At Tinker001 said, look at your physical cable. Make sure it matches.
Yes. But before I look at it, Johnny!
Super chat, where you at? Let the party go. Lights up, feel clap in this awesome show.
Ah, Johnny, thank you for the sex. 67 of them. Yeah, pink LED fund. I have some pink LEDs somewhere. I got many years ago, I got an LED sample pack which had a wide variety of LEDs in it, of all different colors, and including purple and pink and some other
Question, but what
obscure
if it got
colors.
too much heat from the soldering gear on and got bad?
Yeah, it's possible I killed it, Henrik. I might have overheated it. And the yeah, some of the LED colors just look amazing. The purple ones look fantastic. They're so good. And also, that was when I fell in love with emerald green LEDs. So there are normal LEDs that are green, and then there is green and there is emerald green. And emerald green is like this deep, rich green color. They look so much better than normal green LEDs. So, yes. LEDs come in all sorts of really funky colors. Okay, back to this. What am I doing? What am I doing? So, what the color we want is, it should go red, black. I'm just looking at it now. Red, black. Now, SDA is next, which should be blue, and then SCL, which is yellow. And it is. Yes, it matches. I just had a look physically at the thing, and it does match it. Henrik says, you had datasheet open. What temperature it suggests for soldering? Yeah, I should look at the reflow. Here we go. IR reflow profile. Preheat temperature range and timing 150 to 200 C for 60 seconds to 180 seconds. Timing maintained above temperature 217 C 60 to 150 seconds.
At Tinker001 said, do the colors match up at the plug end?
Oh, that's a very good point. Do the colors match up at the plug end? It is going black, red, blue, yellow. Now, what does it show on here? Black, red, blue, yellow. Yeah, it matches up at the plug end. It's also possible that, well, there are many things that are possible. Where are we? I'm going to come back to here, do this, and I'm just going to get onto, I just want to show you what happens. So this is tester 3, which is sitting on the bench just to my right at the moment. If I do I2C detect minus Y1, yeah, you see how fast that happened? Watch this. Bang. That is how fast I expected it to run. You can see that there is a device here at hex 10. That is an AD5593R. And then we've got 40, 41, 42. Those are the three INA 260 current and voltage sensors. And then we've got a device at hex 70. That is the I2C multiplexer. So this is what I was expecting to happen, except that on the other Pi, on this one, I was expecting to see a single device at address 10, which is the color sensor that I just connected. I am sad and disappointed. I am angry and upset, to quote from one of my favorite video game characters.
At Tinker001 said, might be time to introduce the old Pi to Mr. Hammer.
Mr. Hammer. Yeah, it's funny that it introduced the pause in the middle there because it thought it was the end of a sentence rather than an abbreviation. So, so many questions. Why does this take like 1 second per thing to do the scanning? Is is I squared C actually in existence? I think it is, because if I do this on bus 0, it says it can't open it, which means that, oh, come on. Which means that dev I2, oops, I type good, I2C1 would exist. Now let's see what happens there. Oh, nice, I2C2? What?
Use known working I2C random module to test
What?
it out. Does the I2C even work?
Yeah. What? What is going on here? This could be because it is such an old Pi that it is electrically different. And okay, so the deal normally is on a Raspberry Pi there is I squared C bus 0, which is used, it's only enabled briefly at startup to look for EPROMs for Raspberry Pi hats. It reads the EPROMs to discover what is currently connected to it, and then it disables I squared C bus 0. So it goes away again. But I squared C bus 1, which is the secondary bus, is used for, that's the one that's brought up onto the header, onto the expansion header that you can use for your own devices. I have not seen a bus 2 before. I don't know what's going on there. This is all very weird. So, okay, we can get around this. We can. I'm thinking this through. We can connect this to the Testomatic. Let's do it this way. Oh no, but then we've got the device at 10. Ooh, but I can disable that. Okay, if I do, I could either just unplug it or I could disable the multiplexer. Like I could deselect the channel on the multiplexer. So, what have I got on this machine?
The second bus seems to be used for HEDMI only Google SAID.
Oh, okay. Well, that makes that makes sense, because HDMI uses I squared C for discovering device capability. Select, where is select? Oh, select module, cat, select module. So I'm just going to do, this is a nasty hack. Let's do this. I'm going to unlock it. Oops. Channel lock acquired on 5, and now if I do I2C, no, stop that. I'm going to do I2C detect on that. There, now, see, device 10 has gone away. That's because I deselected the channel
Can't you
on
just
the
test another
multiplexer.
random I2C device on it like OLED or SMT?
Yeah, I could, but that is not the quickest way to get to an end result. All right, here we go. I've been procrastinating and trying to avoid this, but let's just do it. So I'm going to kill that Pi, which is the one that the thing is currently plugged into. And I am going to do something slightly dodgy. Slightly dodgy. I'll show you. You will see. And I'm going to try to do this live without shutting this Pi down, just to make it even more dodgy. Here we go. Okay, here we go. Let the dodginess commence. As if I haven't been dodgy already. Now, over here. Let's do that. Just for Pete, because he likes to look at my beautiful face. I'm going to disconnect that and that. Pull all of these. I've got this breakout here into the Testomatic. The focus is set to the wrong point right now, but you'll get the idea. Now, I've got I squared C coming out here. This is the bus that I want to talk to. So I'm going to take this. You can't see this but you will in just a moment. I'm going to get the, I'm going to try using, oh come on, why won't this come off? I'll use a different thing. I will use this, yes. Okay, I have here the Arduino Shield version of the quick thing. Now, it's got 4 sockets on it. They should all be wired in parallel. And I can use this as like a multi-way thing. So what I'm going to do is, I'm going to fix that focus because that is annoying. To about there, that'll do. So what I'm going to do is plug, which way around? That way. Plug the sensor into the Arduino Shield. Then I'm going to take, if I can find them, I had them here. Where are they? I had a bag of connectors. So I've got these quick connectors. Oh, here. Okay. These are quick connectors with, oh come on, they're tangled, with pin headers on the end. So now if I plug this into here, that should now allow me to plug these pin headers into here and everything should be happy. So I want ground into 3.3, where is 3.3 volts? There. No, not ground. What am I saying ground into 3.3 volts? I want ground into ground. Would make far more sense. Ground goes into ground. Then I want 3.3 volts into 3.3 volts. Now, which one is which? On this header, blue is SDA, yellow is SCL. Okay, so blue goes into SDA, yellow into SCL. So now in theory, this sensor should be connected to the I2C bus on the Pi. Let's find out. So now if I run this scan again, we'll see if device 10 turns up. Yes! Yes! All right, so whoo, we are making progress. So now we have the device. And now let's go back to our AI overlords and see what happens with this. Oh, this is using SM bus, not SM bus 2. Oh, hang on, it says here it's using the SM bus 2 library, but it's doing an import on SM bus. All right. Let's see what happens. Get that out of the way. And I'm going to do vim read color sensor.py. And I'm going to blindly, whoops, what's going on there? I'm going to blindly insert the AI generated code. Why? What? What? Hang on. All right, let's do that. Let's do this again. That's better. I don't know why it ended up with all of those. In fact, let's do user bin env python 3, just because I'm lazy. So we're doing bus 1, which makes sense. We've got address hex 10. We're doing that, we're reading that. Yes, and we wanna do, yeah, that. And then read. And we're not getting anything. Okay. We're getting no values. That's sad. We're also not getting any errors. Button stuck. Yeah, I don't know what was going on with that. Johnny. You with your newfangled nano. You youngsters. Point an LED at it, says Tinker. Yeah, what I should be able to do... Well, I am very surprised that it's saying 0. I really don't think this is working because there is general ambient light in the room. I should be getting at least something. But what I'll do is I'll use my phone torch and shine it straight at the sensor. And we're still getting nothing. Woo! So... RGB equals read color, print, blah, read color. Okay, let me see what... what? Oh, that was Hugh. So, Hugh is coming to see me. That is the upshot of all of that, the messages from earlier in the stream. And it's kind of hard to organize when I'm on a stream. So, I'll have to get back to him in a second. All right, what is Python telling us? So import SMBus and time. So time is just for the delay. That's easy. So SMBus, we're calling bus 1. We've got address 1. Okay, as an experiment, let's try this. I'm going to just read from an address that we know does not exist. So now what happens? Do we get an error? Yes, that's good. Okay, so we know at least that that it is connecting to a device at hex 10. Reading RGB, C and I channels, red, bus read word data, blah, and returning red, green, blue. We're assigning the values here. Yeah. There's not really a whole lot that we could simplify from this point of view for debugging. What I could do is just do, let's do this. I'm going to simply return a value directly in here, blue, and I just want to see what that is before it even returns. Yeah, so the value, it's not that the problem is not that the value is not being passed out properly. It is reading a 0 here. Now, what is highly likely is that there is far more complication in the way that you talk to this device than just reading the register. So, and I expect that what's happened is that that's Hugh calling me. I'm still on the stream. Hang on, I've got to send him a message saying I'm still on the stream. I'll call in a few minutes. So, where are we? Where are we? That's right. It's totally thrown me. Yeah, Michael says, to be fair, the stream should be done by now. No, it shouldn't. I'm only 15 minutes overtime. Tinker says, add in registers 4 and 8. Yeah, now where was the data sheet? It's back here in one of these windows somewhere. It's not that. Let's get rid of that. Get rid of that. We don't need that anymore. We've got this, and did I must have just minimized the window. Where is the data sheet? Here it is. Okay. So other registers that we can read, not there. 4 and 8 are the other. Device ID. Okay. Command code, shutdown setting, SD1 is power on. Oh, yeah, here we go. Look, it's probably shut down by default. So in order to 0, power on all channels, power on those channels. So what we probably have to do is write...
Can you check Discord DM?
Yes. Is it relevant to this? Let's see. Oh, okay. Include wire. Yeah, Google gave me this for Arduino. Yeah, so join the bus, that address, command code to read ID register, which is reading 0C, which is there. Yeah, okay. And reading data channels, example of library functions for configuration, sensor begin, sensor end. Yeah, so that's not showing the actual functions. In the begin function, it is probably setting this bit, so bit 15, in the command code to 0, which is power on, instead of 1, which is shut down. So yeah, I think it's quite likely that this is the problem. It just needs to be initialized and told to go into power mode. By default, it's going to set all channels on, or you can shut down R and B. Shut down R and B. That's not very nice for people who like that style of music. What else have we got here? DG, gain, got some reserved things, sensitivity value, integration time setting. Okay, yep, so we can make it run more slowly and presumably get more accuracy or something. So active and force mode, trigger a single measurement, shutdown setting, SDO. Why is bit 0 and bit 15 shutdown setting, SD1 power on, SD1 shutdown, SD0 power on, SD0 shutdown. Why is there a shutdown setting in both? So it's SD0, SD1 in both bit 0 and bit 1. Okay, for power on, both SD0 and SD1 have to be set to 0. For shutdown, have to be set to 1. Yeah, cool. All right. Now this is all making sense now. So what it all comes down to is that by default, it will come up in a shutdown state. So I need to write to register 0 in order to set all of these settings. So it's a 2-byte register, and I need to structure it to set these bits appropriately, which is pretty straightforward, but it is now 20 minutes past the end of stream time, and Hugh is on his way. So I really need to get back to him. If I start diving down this rabbit hole of doing the initialization function, it's going to take a while. So I'm not going to do that right now. regconf equals 0x00. Could read that register first to confirm too, says Stephen. Good point. Good point. Let's I think working code in your DM. Write conf print while true read. Reg is read channel. Okay, so Henrik has just been dropping code to me in DM. Initialization, power on, write conf, blah, print, power on reading channels. Why does that? Ah, so if you write all zeros to that, then... okay. Okay, I will... I will... let's see if we can munge something together from some of this code. Write conf. All right, def write conf. Let's bus write word data. That address regconf. Oh, it's just address. Sorry, I'm trying to munge together regconf example code that. Yeah, here we go. Regconf. Oh, actually, stuff that. I'm not even gonna. I'm munging together code from several different sources here. So this may be 0. Yeah, so register 0 is the register conferent. Value 0. In fact, let's do. Let's do this. This is really dodgy. 0x. And I'm going to take that down to, where will I do it? So I've got to do that once. Then let's do this. Bus is that. I'm trying to simplify as much as possible. So let's get rid of that. So all I'm going to do is write all zeros to register 0 on that device. All right, this is nasty and crude, and let's just see what happens. All right. Oh, what? It's working. I think, kinda. I'm going to move it, and let's see the values change. Oh, check that out. So green has gone up, and now what can I point it at? All right, I'm going to point it at a blue PCB. So this is a very blue source. And what have we got? Well, it's quite dark as well. We've got red, green, and blue, all with low values. If I point it at the point it up at the ceiling, the values go up. Red has gone up, green has gone up. And I'm just trying to find, I want some colors to point it at. What have I got that is a very distinctly red, green, or blue color? I have a highlighter. I'm going to point it at the reddish colored highlighter, and let's see what happens. So red. Now part of this, of course, is that the level of illumination is changing. Normally you would add an LED or something with this to bounce light off stuff. So that is showing green is higher, and if I move this away, it's now pointing at the ceiling. Oh, I know what I can do. There are LEDs on the Testomatic. Hang on, it's a pity that I can't show both of these at the same time. So this is the Testomatic, and under here, you can see the reflecting off my finger, the LEDs.
Pointed at your LED sign, that's red.
Oh yeah, that's true, but it's also far away, and I want to get this up close. So what I'm going to do now is I'm going to switch back to the other view, but I'm going to move this sensor over near these LEDs, and I want to see if the values change. So now we are back on the console. I'm going to put this, all right, this is pointing right at the green LED now. It's right in front of it. So we've got, yeah, you can see the green value is 65,000, like it's maxed out. Red is lower and blue is fairly high as well. I'll move it to the red LED. So it's now pointing directly at the red LED. You can see red is proportionally higher, blue is very low, green is low. And then I'll move it to the blue LED. And you can see the blue value is high and red is very low, green is kind of in the middle. Yeah, okay. So I am shocked, I tell you, to report that this is working. It is working. So, Henrik, thank you very much for pushing me to keep going on it and dumping some example code. I know the only thing I ended up extracting out of Henrik's example code was a butchered version of initializing it by just writing all zeros to the register. Because if you have 0 in bit 15 and 0 in bit 0, that puts it into power on mode. Reserve doesn't matter. Trigger is setting to no trigger. 0 here is setting to auto mode. 0 here is setting to 50 milliseconds. 0 is high sensitivity. Reserved, it's all set 0. For here it is setting default. There it is setting default in DG. There it is setting all power on. Yeah. So the simplest case is if you write all zeros to the configuration register on the sensor, it starts in a sensible state. That seems pretty cool. Very nice. Okay. Well, we actually have success. We end a stream with something working. Amazing. Amazing. Henrik asked if I copied the full code, would it work? The way it came through in the chat was a combination of explanations from the AI plus the
If we'd copied the
plus
full
chunks
code,
of
would it
code.
work?
And so I'd have to edit it anyway. That was actually why I didn't just copy the whole thing and paste it into a file to run it. It's because it's got the references to the datasheet and stuff mixed in with the chunks
And
of
Amanda
code.
_RFT said, yay.
Yep. So if I extracted the pieces of code from what you sent through and compiled it into a single script, it probably would work. It makes sense. It's doing the it's got a specific function for writing to the configuration register, and all I did was take the 0 value and write directly to the register. And oh, okay. So let me grab this. By way of background, what Henrik just did was paste vim read sensor Henrik. He just sent me. What am I going to do? I'm going to do user bin and Python 3, and then I'm going to stick in Henrik's code here. So we've got address 0, then registers, yeah, for the different types of data. So this is the write configuration register function. Then we've got read channel, and then we read the different channels out. So with this, what it's doing is reading a single channel, 2 bytes, combining them, and then returning it. And hang on, write conf. Okay, so what it's doing is writing the configuration with a value of all zeros, then looping on reading. So let's read sensor. Helps with the space. Read sensor Henrik. Read sensor Henrik. See what happens. Yes, we're getting values. Why is G0 and C0. What? There's probably some weirdness going on there. IR 1000. Let's see if I block it. The other illuminance values go down. IR seems to be at 10,248 no matter what. So it doesn't look like we're getting proper values. What is going on here? So we've got registered. I don't think these registers are correct. RGB, that is not 8 and 9. That is... where are the registers? They are red, green, blue is 5, 6, 7. So let's fix that. So red is 5, 6, 7. Then the C data and the IR data. What registers are those? So C is register 4. IR is register 8. Okay, so that's register 4. This is register 8. This should fix it, I believe. And this is why we do not trust AI. It's good for, yes, I'm going to stick my hand over it. The IR level has gone down. And then I'm going to point, what will I point it at? I need a heat source to measure IR. Those values that we're getting are very large as well. I think it is messing up the bit shifting on combining the 2 bytes. So I think if we come back to here, see how it's doing the bit shifting here? So it's taking the data and it's bit shifting and ORing the 2 bytes. I think it's got those mixed up. So, but anyway, I'm not going to keep pursuing this. What we have here is enough success to prove that we can now talk to this sensor and get values out of it. And that makes me happy. Yeah, this line right here, this is where it's screwing up and getting the dodgy values. Cable Tie says, surely the IR should go up if you put your hand on it. Oh, Tinker says, point your soldering iron for IR. Yeah. I know, I want to keep going, but I'm mindful of the fact that I'm now 35 minutes past. I told Hugh that I would be finished streaming at 12. He's traveling from some distance to come here, and I don't actually even know where he is. So I really need to finish the stream and figure out what's going on. But what I will do is read color. Okay, I will do this one last little thing. Red, green, blue. Let's do chroma and IR. Okay. So we had chroma. What register was chroma? Was it 5? I can't remember. See, I don't even know if it is chroma. Oh, clear channel. Clear channel LSB data. All right, so it's 4. Let's do clear channel. I don't know what clear channel means. It means reading the data sheet to figure out what's going on. And IR was register 8, I believe. So now we can do this, and we can go clear. What am I doing? RGB. Oh, and I'm going to have to do that as well. So that's going to be C, and IR is, what do I call that one? I'm just going to call that I, just as an integer. And then up here, RGB, C, I. Okay. Does that look sensible? Or at least as... looks all right. Read that. No. Okay. Let's just forget history. Read color sensor. Okay, so we've got a clear value, an IR value. So if I put my hand over it, let's see if the IR value goes up. Oh, it goes down. Does that mean that I am colder than the environment? And if I point it at my face, okay, yes. I'm going to stick the soldering iron near it. So I'm going to. It is pointing right now at the soldering iron tip, which is currently at 370 degrees according to the soldering iron, and moving it. It just went up to 15. Put the soldering iron tip in front of it, and it drops down a little bit. So there's something odd going on with the IR channel. I don't know what is up with that. And I don't know what clear even means. Like, what is clear, the clear channel, as opposed to the red channel? I don't know. But anyway, I think that is enough success. We have values coming back from it, and the RGB values at least do seem to make sense when I move it near the LEDs. And that makes me happy. It needs visible IR, says Henrik. Oh, I can't see IR. IR is invisible to me. Tazzy says my favourite colour is clear. Yeah, that is a pretty good colour. I like clear. Okay. Yes, as Cable Tie says, I better go because I achieved a result. If I keep going, I'm going to screw up my progress. So, David said, is clear just brightness? It may be. It may be. I don't know.
You electronic devil, go finally and get a burger. I know you want it.
Yeah, I want something. My stomach is very, very empty right now. So, stereo. So yes, I am going to go. Thank you very much for coming along. We had a successful stream. We got something done. We soldered something. We wrote, I'm going to say in quotation marks, we wrote some code. We basically stole it from AI. And we got a result. So that is fantastic. This week, Amanda wins the Nerd Brag competition with 5 Nerd Brags, but the rest of you, the rest of you need to get on it. I haven't actually given my Nerd Brag for this week. What have I achieved this week? Doesn't feel like anything very much. What have I achieved? I know what I achieved. I put in the ventilation.
Your fan mail a tasty burger, maybe.
Yeah, I put in the fume extraction for the reflow oven. It is now all like proper duct and through and stuff. Last week I showed you the 3D printed fittings for it. It is now fully installed, fitted. The parts are in place. The extraction fan is mounted to the wall. It's all controlled off Z-Wave. It's all good. So that's my Nerd Brag, fume extraction. I'm no longer choking myself. So, have an awesome week, and I will talk to you all next week, the last stream before Christmas.